All right, and let's take a look at problem number 2. Problem number 2 is asking us to find the currents I1 and I2, and they're identified for us here and there. Okay, so we will go ahead and take a look at what we have here. Okay, so we see that current is going to leave this battery, hit this node, split off this way, and then split off that way. And we see that that current's going to travel and travel. It'll meet back up here, and it'll come back to form I1. Okay, and then I1 is going to be the same on the other side of the battery because current in the wire can't change. So the current's going to stay consistent along that wire. So we know all the resistor values. We know the battery voltage. We just don't know the current for anything. But if we were to break it down to one voltage source and then one resistance, we can use V is equal to IR to then figure out what I is equal to, which will be V over R. Okay, so let's do that. We see here that we have these two resistors. They look like they're in parallel. So we'll go ahead and say R parallel 1. We'll just call it parallel 1 actually. So call that parallel 1. And then over here we'll say R parallel 1 is equal to 18 times 9 over 18 plus 9. Okay. And that's going to be equal to 6 ohms. Okay. So if we go ahead and redraw our circuit, plus minus 20 volts. This is R parallel 1, which is equal to 6 ohms. Over here, this was 4 ohms. Okay, and we see now that I1 is going that way, and we still have I1 over here. So we have I1 just circulating throughout this one loop. Okay, so we have a couple options. We can do a KVL on it, where we go sum the voltages, and then we would find our current one that way. I'll say for this specific problem, that would be the long way to do it. For this one, we'll just go ahead and say that if we were to add these two in series, so series 1, our series 1 will be 4 plus 6, which will give us 10 ohms. Okay, so 10 ohms, 20 volts. We know I1 circulates throughout here, so we can just say I1 is equal to 20 volts over 10 ohms, which will give us 2 amps. Okay, so that will be our I1 value. Okay, now that we know what I1 is, if we were to bring it back, and we see that at this point I1 branches off, we can say that we know that 2 amps goes this way. And then we know I2 goes this way, and we know some value I3 goes that way. All right. But we want to find I2 for this specific problem. Okay. So if we were to write our current division equation, so current division, this would be equal to R equivalent over, I'll call this R2 times I of S, which when we sub everything in, well, we know that R equivalent is going to be R parallel 1, since we found that already. And then R2 will just continue to be R2. Our I of source, the source current that's being broken up, is just going to be equal to I of 1, because we said up here, I of 1 enters these two branches and travels down both ways. Okay, so this will be equal to our parallel 1, which we already found up here. Okay, so this will be 6 ohms over R2, which is 18 ohms, and then I1 is 2 amps. Okay, and this will give us a value of 0.67 amps for I2. Okay, and then let's just go ahead and solve I of 3, which we said, we'll say like I of 3 is this one, just to see if we can do it. So I of 3 would be equal to R equivalent over R3 times I of S, which would be, once again, R parallel 1 over R3 times I of 1. Okay, and when we go and sub those values in, we will get 6 over 9 times 2 amps, which will give us 1.33 amps for a value of I3. And if we did the quick KCL on it right here, 0.67, 1.33, we'll see that 2 coming in is equal to the 0.67 plus the 1.33. Okay, so that checks out.